All right, today's notes will be on our third day of section 1.6. So still using absolute values. We're going to do some applications for this, which is called tolerance. So this will use absolute value inequalities as in applied situations. So your definition of tolerance would be the measuring of the allowable distance between a given measured value and an accepted value. Tolerance, if we calculate it mathematically, would be half of the difference of your maximum and minimum acceptable values. And we can use absolute value inequalities to describe the tolerance. Okay, so let's take a look here at a few examples. So this first example I pulled out of the math book. I did not make this one up. So in car racing, a car must meet specific dimensions to enter a race. The desirable height is 52 inches. The greatest acceptable height is 53. The least acceptable height would be 51. Using H for height, find the following. All right, so these are typically the three things that we need to find. Maybe it'll be in this order, maybe it will not when you find them in your homework. But this is the order I typically like to go in. I like to talk about the compound inequality first. Make sure if they tell you what variable to use, you're using that same variable when you're typing those things into Math Excel. Otherwise, it's going to mark it wrong if you just use X for everything, if it didn't say to use X. So be careful about that. So my compound inequality is going to tell me what can basically the height be, right? Because we have a desired height that is between your highest and your lowest. Okay, so my height must stay under, or it can be 53. So the height would have to be less than or equal to 53, but also greater than or equal to 51. So that would read 51 is less than or equal to the height, which is less than or equal to 53. So all of my heights for these cars must be between 51 and 53 inches. Okay, that's my compound inequality. To find the tolerance, you can go back up to that definition. Tolerance is 1/2 of the difference of the maximum and minimum acceptable values. So my acceptable values would be 53 and 51. Those are the maximum and minimum. If I find the difference and I cut that in half, that's going to be my tolerance. So 53 minus 51 would be 2. 2 divided by 2 would be 1. My tolerance is 1 inch. So what the tolerance means is how far off you can be from what is desirable or acceptable for this situation. So hopefully that makes sense, because what we're trying to do is the desirable height is 52 inches, but it's okay if you go 1 inch above to get 53 or 1 inch below that to get 51. Okay, that's what the tolerance means. And how we would rewrite this as an absolute value inequality, it has a similar setup every time. I'd have my variable that I'm figuring out, so height minus, this is that desirable amount, so that would be 52, and this number will be your tolerance. And that's going to be the setup for every single problem when you're writing that absolute value inequality. Okay, we're always using less than or equal to because we do not want to go over the tolerance. Okay, you don't have to solve this because we're kind of working backwards. Up here is the solution to this inequality. Okay, if you remember, we did problems like this. We did h minus 52 less than or equal to 1, but greater than or equal to -1. And if I were to solve that and add 52, I'll get my 51 less than or equal to h less than or equal to 53, which is what I have above. Okay, so we don't have to solve this, but I'm showing you that when you solve it, you get the answer that's above. So we're kind of working backwards. We're kind of looking at what is the minimum and maximum, how far off can it be, and then I could come up with that inequality. Okay. All right, for number 2, look at a different situation. So Mrs. Barclay finds 60 degrees Fahrenheit to be an acceptable temperature. She prefers the temperature to not go above 80 or below 40. Use T for temperature and find the following. Okay, so T for temperature, we're going to write the compound inequality. So I'm looking for that minimum and maximum temperature. So we do not want to go above 80, so less than or equal to 80 for that temperature, because then it's too hot for Mrs. Barclay. Okay, but we also don't want to go below 40 because then Mrs. Barclay is too cold. Okay, so that means the temperature must be greater than 40. So there's my compound inequality telling me the temperature needs to be between 40 and 80. To find the tolerance, I need to find the difference from my maximum and minimum and divide it by 2 to show how far off I can be on both sides of that desirable amount. Now, some of you could probably do this in your head, totally fine. You can tell that the difference is 40, 40 cut in half would be 20. All right, or you might be picking up on some other patterns because they told us the desirable amount. Okay, so the desirable amount is always exactly in the middle of your minimum and maximum values. Okay, so you might be able to mentally go, well, that would be 20 above and 20 below to get to 40 and 80 from 60. So you might be able to come up with that tolerance in your head, which is okay. Okay, so then for my absolute value inequality, we're always using less than or equal to the tolerance because that's how far off we can be. We used T for temperature. I'm always subtracting because I'm finding those differences between these values, and then it would be that desired amount is 60. Okay, so if you don't have any work necessarily for these problems, that's okay. You don't have to show me any work necessarily. If you can do that in your head, if you want to show those steps, go for it. Okay. Right. Here's our next example, number 3. Suppose your speedometer in your car varied its accuracy between +6 and -6 miles per hour from its setting. If you set the cruise to 60 miles per hour, let S be the actual speed and find the following. Okay, so this one's a little bit different in how it's worded and what information they give us. So speed, right? I need to find the lowest speed and the highest speed. This time they didn't tell me that. Okay, we have the desired amount, and I actually already have the tolerance because the tolerance tells you how far off you can be from that desired amount of 60 miles per hour. So I could be up 6 or 6 below that speed. So I already know my tolerance is 6. Okay, this time I didn't have to calculate it. You're kind of calculating the lowest and highest possible miles per hour. So if I take 6 away from 60, 54 miles per hour is the possible lowest it could be going if I'm cruising at 60. Or it could be 6 above, so that could be 66. Okay, or anywhere in between there. When I write that absolute value inequality, less than or equal to my tolerance of 6, and then we're using S for speed minus the desired amount would be 60 because that's what I want my car to be set at, and I hope that it is true to that speed that I'm setting it at, but that it could be off. Okay. All right. My suggestion would be try number 4 on your own before I go through it. See if you can set it all up yourself. Give yourself that little test here because we're about done with this lesson. So I'd pause the video, fill it in, press play, Okay, but your cell phone is recommended for temperatures from 30 degrees Fahrenheit and 90 degrees Fahrenheit. Use T for temperature and find the following. Okay, so T for temperature, we gotta stay below 90 so our phone doesn't get too hot. But we also gotta be above 30 so our phone doesn't get too cold. Okay, so now we'll have to calculate the tolerance again. So if you can do this in your head, great. If not, subtract your highest and lowest and cut it in half. So we would get 60. 60 divided by 2 would be 30. So 30 degrees would be our tolerance. So we can't go over 30 from the desired temperature. Now it doesn't say the desired temperature above, so this time we'll have to figure it out. So a couple different ways you could figure this out. You can use your tolerance, right? I know how far off I have to be from 90. So if I go 30 degrees below 90, that would be 60. So that should be my desired temperature. Or I could go from what's below is 30, and I could be 30 above 30, and that would also be 60. Or I could figure out what is the exact middle number between 30 and 90. So I'm finding that average, so I'm adding those two together to get 120 divided by 2 is also 60. So a couple different ways you could come up with that desired amount if they don't give it to you. Okay. All right, last example here. This one just says write absolute value inequality and compound inequality for the length x with the given tolerance. So we have a length of 50, the tolerance is 2. So if I write the compound, so my length could be, it's off by 2 meters from the 50 meters. So if I take 2 meters away, 48 is the smallest it could be. If I add 2 meters on, 52 is the highest it could be. And then that absolute value inequality, we can't go over the tolerance of 2. We're using x minus, they gave us the length that's desired. And that would be my answer. All right, that is it. Like I said, there's not a ton of work to be shown on here. Hopefully this assignment will be pretty quick for you overall. But as always, if you're having trouble, reach out and ask questions.